This is a generalized discussion. This ring, it is carrying a current I. Already we kept B bar, no? So let me just keep B bar in this direction. What direction the torque will act? I'll change B bar like this. Then here B bar is into the plane. So B bar, let it be somewhere here. Uniform magnetic field like this. So just rough idea. They may ask you something questions in matching like this. Yeah? They just ask you, what about the torque, zero, non-zero, stable, unstable, about which axis the torque will act. Now, what is M bar? M bar will be out of the plane. In all the cases, let me pick up current in anti-clockwise sense. First one here. So how is M bar? M bar will be along Z axis. So M bar cross B bar. So how the torque should be in this sense. So the direction of torque will be, torque is set up about x-axis, will be directed along negative x-axis. How torque is,
the sense of rotation will be in the opposite directions.
Yeah, I'll change it. So it'll be like this arrow. Yeah, it'll be like this. This will be the sense of rotation. How M bar will be along Z axis, and curl fingers from K cap to, from Z axis to Y axis. Then the thumb will be along negative X axis, and this will be sense of rotation. Is it a stable or unstable equilibrium? Not stable, not unstable, because the reason for that, what is the net torque? Non-zero. What about net force? Net force, zero, non-zero, will be zero. What about the potential G of the system? What is the angle between M bar and B bar? 90 degree. Potential G will be zero. Potential G zero doesn't mean that any equilibrium. What about here? Torque will be acting about y-axis. And the sense of rotation will be like this. I'll write alpha nearby that arrow. It'll be easy for you. Here also, what is the net torque? Net torque acting on system. Net torque will be non-zero. Current carrying loop kept in a uniform magnetic field. Net force should be zero. So then what is the potential J? Will be zero. Here, let's come for this case. What about net torque? Zero. What about net force? Zero. What about potential energy? Maximum. So shall I put unstable equilibrium? Slightly rotate it about x or y axis. So what will happen? The dipole moment will act in such a way that it will try to align in the direction of B bar. A restoring torque will be set up. The restoring torque will make the dipole moment to align along B bar. Getting the basic conditions. Next, come for this. M bar is in this direction, out of the plane. M bar, B bar. So the torque will act about this axis. Already previous problem, one problem we have seen, no? It is similar to that. So here the sense of rotation will be, this is alpha, this will be the direction of torque. Alpha also in the direction of torque only. To make you understand, I'm writing nearby that arrow, at least alpha. Means something related to angular motion quantity is what, therefore I'm writing it here. What about net torque here? Net torque here it is non-zero. What about net force? Zero. Potential energy of that will be zero. So therefore, I think you do have some questions. A current carrying loop kept in a uniform magnetic field. Then, what are the possibilities? Torque, net force. You try to see all different cases. I think the first and second are same. Third case, you see net torque, net force zero, potential energy maximum. Here what happened? Net torque non-zero, force zero. Potential energy also will be zero here. I think 1, 2, 3 are same. The third one we brought little bit different thing. Now even it can be minus MB also. Is it possibility where torque zero, force non-zero? Yes, it can happen. So any theoretical questions, you have to be very specific. It's not like something you have to make a guess. Torque direction, torque, M bar cross B bar. Uh-huh. This is torque direction, tau direction. It will be like this. Arrow. Curl fingers in the direction of that arrow, sense of rotation. The thumb will be in this direction. The thumb will point in this direction. So any conceptual question, they may test you torque,